Hello, good morning. Today we are going to start to evaluate limits. That is the questions which are based to find out the limits for the two functions. So here is a remark. If f of z0 is equal to g of z0 is equal to 0, I am having two functions f and g, where f dash z0 and g dash z0, that is their derivatives at that point z0 exist with g dash z0 non-zero, then limit z tends to z0 f of z over g of z is equal to limit z tends to z0 the ratio of their derivatives at z0 only if f dash z over g dash z is continuous at z0. So there is a example to evaluate the limit. Evaluate limit z tends to 0 e the power z minus 1 over 3z if it exists. Fine. So I'm having two functions. Let us consider this first function as f of z, which is equal to e the power z minus 1, and the second function g of z, I am taking it as 3z. Alright. Then what is my z0 point? That is 0. So let's check f of 0. This is e the power 0 minus 1. We know that e the power 0 is 1. So this comes out to be 0. Let's check g of 0, that is equal to 3 into 0, which is equal to 0. Now let's check out the derivatives. F dash z. What is f dash z? This is derivative of e the power z is e the power z, and g dash z, which is equal to 3. Let's check at the point z0, that is 0. F dash 0 is e the power 0, that is equal to 1, and g dash 0 is equal to 3, which is non-zero. We have seen in the remark that g dash z0 should be non-zero. So here g dash 0 is non-zero. Thus, now I evaluate the limit, that is limit z tends to 0 fz over gz. What is fz? E the power z minus 1 over 3 of z, that is equal to limit z tends to 0. What is f dash z0? That is f dash 0, that is 1 over g dash z0, that is g dash 0. This is equal to 3. So the limit comes out to be 1 over 3. Alright? Yes. Hence the limit. Next question. Second example is limit z tends to 0 2 sine z over e the power z minus 1. So the first function is, I am considering fz to be equal to 2 sine of z, and gz is equal to e the power z minus 1. Then f of 0 is 2 sine of 0 is 0, that is equal to 0, and g of 0 is equal to e the power 0 minus 1, that is 1 minus 1, which comes out to be 0. Now we are taking the derivatives. F dash z, that is equal to 2 cos of z, and limit f dash at 0 is equal to 2 cos of 0, which is equal to 2, because cos of 0 is 1. G dash z is e the power z, and g dash 0 is e the power 0, that is equal to 1, which is non-zero. So now thus limit z tends to 0, 2 sine of z over e the power z minus 1 is equal to limit z tends to 0, f of z over g of z is equal to limit z tends to 0, f dash 0 over g dash 0, that is equal to f dash 0 is 2 over 1. So limit comes out to be 2. Next, evaluate limit z tends to 0 sine of az over sine of z. Take your fz to be sine of az and gz as sine of z. Then same steps accordingly you find out the limit for these two functions. So this is an exercise for you. Next, this is the expected one. A very good question. Okay. Evaluate limit z tends to 0, mod of z square over z. Here f of z I am taking mod of z square and g of z is equal to z. Okay, so let's check it. Let's open first. Limit z tends to 0, mod of z square over z. This is equal to limit z tends to 0. What is z? This is x plus iota y. So mod of z square is x square plus y square over, what is this z? This is x plus iota y. So in this type of question there is no need to consider the functions fz and gz. Just solve this and get to your limits. So this is equal to limit z tends to 0. I am separating this, that is x square over x plus iota y, and separating y on the other side. Limit z tends to 0, y square over x plus iota y. Can I write this as x square as x into x? Yes. Plus similarly limit z tends to 0, this comes out to be y into y over x plus iota y. Now we know that x over x plus iota y. Now I am having two functions over here, this function first and this is the second function. Now before going to calculate the limits for these two functions, I have to prove the second function to be bounded and the first function limit z tends to 0 should comes out to be 0. Then we take the limits for the product of the two functions. So I am considering the second function and I have to prove that this function is a bounded one. So mod of x over x plus iota y, this is equal to mod of x over root of x square plus y square, which is less than equal to 1. Why? As we know that we have done this in earlier classes also, that is x square is less than equal to x square plus y square, which implies mod of x is less than equal to root of x square plus y square, which implies mod of x over, can I write x square plus y square root as modulus of x plus iota y? This is less than equal to 1. So, mod of x over x plus iota y is less than equal to 1. So, it is proved that this second function is bounded. Now, about the first function, limit. Instead of z tends to 0, I should write x, y in ordered pair 0, 0, x, which is equal to 0. Now, as limit xy tends to 0, 0, x, this is equal to 0 and the second function is bounded. So, the limit for the two functions now comes out to be 0. Since limit xy tends to 0, 0 of x is equal to 0 and modulus of x over x plus iota y is less than equal to 1, therefore limit xy tends to 0, 0 for the first part, that is x into x over x plus iota y, this is equal to 0. Similarly, do for the second part also, that is this part. Similarly, consider this mod of y over x plus iota y, this is also less than equal to 1. If we write y square less than equal to x square plus y square, on the symmetry basis, this limit is also tending to 0. Prove the second function to be bounded and the first function limit should tends to 0. Then both the product of the limits tends to 0. So similarly, limit x y 0 tending to 0, 0 y dot y over x plus iota y is equal to 0. Hence, limit z tends to 0, mod of z square over z is equal to 0, because this is also 0, this is also 0 and this is also 0. So the sum is also 0. Hence the limit z tends to 0 mod z square over z is equal to 0. Substituting both the values over here, the limit comes out to be finally 0. Okay. Similarly, example 5. Evaluate limit z tends to 0 z square over mod z if it exists. Now mod z is in the denominator here. Okay. So limit z tends to 0. What is z square? This is x plus iota y whole square over mod z, that is x square plus y square under the root. Now opening the bracket, you're having the formula for, that is a plus b whole square. This comes out to be x square, because here iota is also there, so iota square is minus 1 minus y square plus 2 iota xy over root of x square plus y square. Now separating the parts, you will get limit z tends to 0, x square over root of x square plus y square minus y square over root of x square plus y square plus 2 iota xy over root of x square plus y square. So I have separated the parts. Now similarly, limit z tends to 0. जस्ट हमने जैसे पिछले वाले क्वेश्चन में किया था. सो एक्स स्क्वेयर कैन बी रिटन एज एक्स इंटू एक्स ओवर रूट ऑफ एक्स स्क्वेयर प्लस वाई स्क्वेयर माइनस लिमिट z टेंस टू 0 y इंटू y over x square plus y square plus 2 iota take outside, limit z tends to 0 xy over root of x square plus y square. Since the expression is in x and y, so you should write instead of z, xy in ordered pair. So from the very start, I should write x, y tending to 0, 0 because the expression is now in x and y. X, y tending to 0, 0. X, y tending to 0, 0. X, y tending to 0, 0. Keep this in mind always. X, y tending to 0, 0. Okay. The first part ये तो आपने prove कर लिया था पीछे that this limit will tends to 0. So this is 0 as in the earlier question. This is also 0 plus 2 iota limit of x, y tending to 0, 0 x, y over, this is dot, root of x square plus y square. Okay, so again, now this is 0 plus 2 iota. See, your xy tending to 0, 0. So just put over here. Again, this is if as modulus of y is over x square plus y square, this is less than equal to 1, and limit xy tending to 0, 0 of x comes out to be 0. Both these two things happen. One is bounded and another limit tending to 0. So this function is also, the limit for the product of these two functions is also 0. So the whole answer comes out to be 0. Okay. So okay. You can take instead of x, y outside and x inside, this is one and the same thing. So the next, this is a exercise for you, that is evaluate limit z tends to 0, 1 minus cos z. Wait, have I right? Wait, I have to write the final result, that is limit z tends to 0, z square over mod z is equal to 0. Alright, the last example, this is an exercise for you. Limit z tends to 0, 1 minus cos z over sine square z. The answer is 1 by 2. What you have to do, that is, you use sine square z as 1 minus cos square z over here in the denominator, and using the formula a square minus b square in 1 minus cos square z, you will get 1 minus cos z into 1 plus cos z. So 1 minus cos z and 1 minus cos z will cancel out. You will be having 1 over 1 plus cos z. And then apply the limit. You get the answer 1 by 2. Okay. So in the next class, we are to discuss about simply connected domains and Jordan curves too, plus harmonic functions. So thank you.